Hello and welcome. My name is Chris Dale, and I'm back here again with another Natas web hacking challenge. Today we're faced with Natas15. What is this all about? Well, there's only one way to find out. Let's try use the application. Check to see if a username exists or not. Admin does not exist. Alright, what about a random string? Does not exist, as expected. What about Natas15? Because we are actually on Natas15 right now. Does this user exist? Let's check. No, it doesn't. What about the next level? Natas16. Oh, yes, that user does exist. So in just using the application here, we can basically determine that there is no such user as admin, and there is such a user as Natas16. Now, of course, that's a username vulnerability, username enumeration vulnerability. However, that's not what we're going to use it for here. We gotta explore further. Is there some kind of vulnerability in this field? Say, for example, if I input a tick, that user does not exist. All right, what about a double quote? Error in query. Yeah, we got a SQL injection. Perfect. Perfect. So, a SQL injection, Natas16 with a double quote produces a user an error in query. So what if we do a little and 1 equals 1? Woo-hoo-hoo. We fixed the query. What about 1 equals 2? User does not exist. So that is very interesting, my friends, because what we have learned is that we have something like this. So let's start from, say, a table called users. So I'm just coming up with a name here, where username equals, and we have input from user in here. This is where we are currently putting in information. Then we have a query terminator at the end here. Now, with this query, what we did is that we inputted a little tick, a double quote here, sorry, and the query failed. It said error in query. Mind you that you might not always see that you have an error. You might just get a redirect to a front page. Maybe you just get a username does not exist as a default, but there might still be SQL injections. However, what we did then is that we said Natas16 like this, right? This produced a query error. And then we did space and 1 equals 1. This is our input. Notice how the 1 equals 1, the final double quote here is added by the developer, so we don't need to add that. But notice how we are forcing this to be a true, and we are fixing the query so it no longer breaks. And when we change the 1 equals 1 to 2 equals 1, it says that no such user does not exist. So this produced a no such user exists because the left side of the AND statement here, the Boolean operation, that one is true, but because of the AND, we have to have both sides to be true, and 2 equals 1, that's not true. That's false. Hence, the query fails. But 1 equals 1 does work, and we can pretty much then further on attack this database. All right, so where would we go from here? We have, so let's start from users, where username equals our input. We probably want the password for Natas16, don't you think? That's where I'm thinking we gotta hunt, but where is the password stored? In which table and what column? There's a lot of questions to be asked here, so we gotta explore. But we are flying kind of blind. We only have on either no such user exists, a false, or that user exists, a true. So we only have a Boolean true or a Boolean false to work on here. We don't have an output. We don't see any rows coming back to us in the web application. So it's basically more or less a blind SQL injection we're working on here. So what we could do potentially is we could say whatever, double quotes, union all, select 1, semicolon hash. What this will do is that I will break free with the union all. I will break free from this left side of the query. And I'm going to be stacking another query on top of the results of or beneath the results of the left side of the query with this. So this is a new query I'm starting up now. So I'm saying, do whatever you want to do on the left side, but I'm now starting a new query where I can select more information. Cool. So let's do whatever, right? And then union all, select 1. And I do a semicolon hash. The semicolon is a query terminator, and a hash will comment out the rest of the query. So that will remove this extra double quote, which is put there by the developers, and so on. So this would maybe error or maybe work, but it says error in query. And based on your knowledge of SQL injection and databases and so on, you could probably guess that, hey, this error might be there's not equal number of columns on the left side of the query as of the right side of the query. There is a set number of columns on the left side here, and on the right side you need to have exactly the same numbers of columns for the query to work. So how do we know how many columns they're selecting over here? We don't, but we can very easily find out by simply doing a little comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, and we select to see how many, and we guess to see how many columns there is. So when we add a 1, comma 2, it says this user exists. There's no more error in query. Notice what happens when we add another column here. 1, comma 2, comma 3, error in query. So we have learned that there's in fact 2 columns on the left side here. And then we need to have 2 columns on the right side. So, okay, that's good news. We can then do union all select 1 and 2, and we can do a from. So which table should you select from? So say from information schema, the database we've been using before, the metadata schema. All databases have this schema, more or less. It basically describes the database. What databases you have, what tables you have, what columns you have, and so much more. And we can select information from the tables schema here. The tables table. So let's try this query here. So we're going to input this, and we're going to check to see if that works. This user exists. That means this is true. So that means that this returned false, no rows. There is no such user as whatever. However, the union all select 1 and 2 from information schema on the right side here, the tables, this has now returned rows. Hence, the operation says true. Yes, we are getting results back. This user exists. So we can use this to our advantage. We can now say we can limit information here. We can do a where table name equals something, for example, or we can do other things. The thing is, we don't have knowledge yet. We don't have information about the database. So we need to learn. We basically need to explore and learn what this system looks like. So instead of union all select from information schema tables, instead of just doing this, we need to understand which tables do you have. And to learn from that, we can do a where substring table name, and we're going to select the first character and only one character if the first character of the table name column, if it's equals A, for example, then we're gonna return a row or more. So why don't we try this query here? So this says error in query. Okay, let's see. That's because we don't have a little hash here. All right. Notice it says this user does not exist. So this is false. When we check to see if any of the table names, if the first character equals an A, we want to have a row result coming back to us, but that did not work. There is no such user. What about B? No such user. What about C? This user exists. So we now know there is a table that starts with a C. And there's probably many tables that starts with a C, to be honest. Because if you look at a MySQL database, which I have here, I have my own MySQL database. You should also install your SQL servers and MySQLs and so on, just to explore and learn. You will see that I have a bunch of databases here, first of all, and some of these are built in, and also these are built-in tables, default tables of the default databases. You can see that these all start with C. There's nothing on D though. Maybe I can do, is there something on D here? No such thing as D, but what about an E? Yes, we have something on an E. This user exists. So we're not really interested in exploring the information schema database or the MySQL database or the performance schema database. So what we could do with our query is we could say where's substring, that's all good, and schema something else than MySQL and schema something else than information schema and schema something else than performance schema, like that. How do I know about this schema column? Well, I basically do this. Select star from information schema tables. Might get it wrong. I might have the column wrong as well. So this query is basically what we're trying to do on the target database. Wow, this is slow. And you can see that the table schema here is what we want to affect here. So the table schema is what we want to manipulate and prevent us from selecting all the built-in schemas. All right. So this query here is much better. This will return much more accurate results in terms of what we can use to target the application. So if I now try to see if there's something starting with, so we have the substring all the way over here, we have a substring equals A. What I'm going to do is I'm going to add this substring to the end of the query. So we're going to do like this, table name like this, and we do this, and substring equals A. So when we do this query, there is no such user that, basically no table that starts with an A. What about a B? And what about a C and a U and a C, C, D, E, F, and so on? But what about a U? And this user does exist. So that's very interesting because we can see that when we try with an A, there's no such user. When we try with a U, there is such a user, meaning that that query returns something positive from us. So what we're going to do is we're going to add this query to our attack here. So this is our current attack. Whatever, fine. Union also like 1 and 2 from information schema tables, where table schema, something else than MySQL, information schema, and performance schema. Why those three? Well, those are built into MySQL. They're over here, information schema, performance schema, and MySQL. The CD call, the damn vulnerable web application here, the PHP MyAdmin, Real7, Test Web App, these are my databases, and those are interesting for an attacker. But really, the information schema and the other ones are not that interesting. And then we're checking to see if the table name from any of these tables, does the first character start with a U? And it said yes, it did. Beautiful. So we need to automate this attack instead of doing it manually. So why don't we start automating here by sending our request to the burp suite. All right, intercept on, check for existence, press Control I, bring it into intruder, and we can see that I now have this this little URL encoded string here. You see when I mouse over it, it says the full URL decoded string. And in fact, I'm just gonna, for the sake of brevity and helping you guys understand, I'm gonna URL decode it in my attack as well, because it can be quite tricky to remember all the different URL encodings and all the different characters. So with CyberChef here, I'm gonna URL decode, and I'm gonna have this string in my attack instead, so it's easier to read. You see, now I have the exact same attack that I input inside of the web form to check if the first character of table name equals an A. But what about, it worked when we had a U, right? So what about the other characters? What about character 2? Is the character 2 an S? For example, let's go back to the application here. So what about the second character? The second character of the table name. Are you equal an A? No, you're not. Are you equal an S? Yes, you are. A U and an S. I'm very suspicious here that we might see users or user or something with a user. But so far, I want to automate this to make the picture much clearer. So the first payload here, we're going to use a cluster bomb here, a double for loop. The first payload is going to be a number. This is the number going through the table name string. So which character of that string should you get? The first character, the second character, the third, fourth, fifth, and so on. So we want to go from, say, 1 to, say, 10, right? Step one at a time. The second payload, which is this one, the A, well, that's just going to be a character, right? It's just going to be an A, B, C, D, E, F, some kind of character. So why don't we use the brute force here with a maximum length of 1 and see what happens when we click start attack now. And you can see that it just goes through the payload, the left payload first. So payload 1 to 10. It goes to check to see if any of those are equals an A, and then a B, and then a C, and then a D, and so on. If we click a request, we click a response tab, we click the render tab, you can see that it says this user does not exist. However, I'd rather have this inside my results column here. So what I can do a grep extract, and I can select this string here. And it will manipulate the table here so I can basically list that output in my table. Makes it much easier. Can I sort on this, for example? And you can see that when I sort on this user exists, you have on payload 1, you have the character U, just like we demonstrated. On character 2, you have the character S. Ooh. On character 3, we have E. We have on 4, R. On 5, S. So basically we have users. Normally, when we have this output like this, we basically copy, we select this, and we copy it, put it into Excel, and we sort this result here, and we sort it on column number B, I believe. Looks good. So you can now see that it spells out users. All right, good. So there's a users table. Beautiful, beautiful. What columns does the users table have, however? We need to explore further. We're not done yet. So we now have information that there's a users table. We need information from the users table. So why don't we expand our query here even further, and we say, whatever, sure enough, union all select, blah, 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 blah. Select from tables, where table schema, we don't need any of that anymore. Table name is now equals users, right? We found out that there's a users table that is not from the default databases. It's in a custom database that the developer put there. So the table name equals users, and a substring of, let's see, well, we don't need to select tables anymore. We need to select columns. What columns? Yeah, there is, in fact, a columns database or table inside of MySQL, which contains the different columns. You can see here the different columns the different tables have. So, for example, for the users table, do you have a column that starts with an A, a B, a C, a D? You see where we're going here? We're now enumerating more information. So we're going to do columns where table name equals users, and then we do column name here. Is the first character of the column name, are you an A? Well, let's check. So let's take this query here and bring it into intruder here, positions here. I'm just going to bring this to the repeater and then back to the intruder so we can say the previous attack. So here, we paste the attack here. All right, so table name equals user, substring here. So we need to do a same type of enumeration again. 1 and then equals A. So we have 2 payloads. Still going to be a cluster bomb, double for loop. We're going to do a numbers from 1 to say 10. And the payload number 2 is going to be, brute force again. So let's try this. Let's just see what happens here. So I'm getting a request count of 0 here. That means something is wrong. It's just a bug in burp suite there. All right, so let's see. We also need to add the grep extract. Of course, I could have added this from before, so I don't have to add it every time, but I keep forgetting it. And honestly, I like to customize my attack while I'm working on them. And here we can see that we do have users exist again. In fact, we can see different payloads here. 1 equals P, we can see 2 equals A, and so on. So we're just going to bring this into Excel. And we're going to sort it again. We're sorting column B. And we have the following columns. P, U, A, S, E, N, and so on. So the problem here is, in fact, so we're going to put this into CyberChef first. And we're going to split on this. And we have this string. So basically, I just removed all the line breaks here, okay? So, does anyone see something funny here? P, U, A, S, 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 and so on. This string here is not proper. And the reason for this is, our query, this query, is basically getting multiple results from our query. So, there's multiple columns that has something with A in the user's table. Now from here, we could basically do a limit. We can limit the results, so we only get one result at a time. And we do this with the limit keyword. Limit 0.1. We can also use an offset of 1. Offset of 0, sorry. So meaning we only get one column and we start with an offset of 0. Let's try this query here. So here we have error in query. So I do have a bug in my query. Just a second here. Do we have the offsets? Oh, gotcha. So let's do this. Start tag. Do we have error in query? I believe we do have an error in query. Error in query. Let's see. I'm going to bring in my payload into Burp Suite here. Sorry, into the web application, and I'm going to debug from there. So limit 0.1. Will this work? Oh. Yes, please remove those A and remove those like that. Gotcha. All right, so that works. But I'm not happy with the limit because the limit will still produce false positives here. It will work better. It will reduce ourselves from only getting one result. Actually, I think this will work. With the offset. I can't remember where I used the offset before, but let's try. Limit 0.1. That will get one result, and we start with offset 0. Just double check here. MySQL limit keyword. Just double check. Whenever you're in doubt, Google it. I trust Google, right? No. Ooh. Can we do a comma? There we go. Limit, offset, and then the count. So we start with offset 0 and we do 1 count. That means we can iterate on this number later. All right, gotcha. Let's try. In fact, I'm gonna configure my attack down here now. I'm gonna do a grep extract. Let's do fetch a response here. Don't be slow. Come on. Why so slow? All right, so it doesn't like that query. So let's do it like this then. Options, grep extract. Mark this text. Beautiful feature of Burp Suite here. And we can now see that when the user exists, we have these A, D, E. We have doubles still. P. Let's see in U. We still have that problem. The offset is not working. You see, we have the character U in payload 1 and also the character P on payload 1. That means that this offset here, this limit, is not working. So why don't we do limit 1, offset 0. Let's try that from here. Limit 1, offset 0. Okay, beautiful. So does this equals on U? Yes. Does it equal a P? Yes. Why view equals both? So U and a P. Let's see. I'm sure, right? User exists with the offsets. Let's bring ourselves back in a more abstract view here. I have to properly manage this attack. I have to make my brain better work this problem. Let's work it from the start. We're selecting 1 and 2, no problem. This returns nothing. And we're selecting from the columns where table name equals users, good. And the substring of the column name, the first character, and only one character, equals an A. And we want to limit our result to only return 1 row, and we start with offset 0. What if I start with offset 1? Oh, yes. No. P does not exist. U does not exist. All right, let me take a look at my cheat sheet. So here we have a limit. So let's see this one. Eh? Here we have a query I'm running on my own database. Whenever you're in doubt, run it on your own systems so we can check to see what's going on in a more transparent way. We can check the logs on our own systems. We can check the data that's in databases on our own systems. So we're selecting start from information schema tables where substring table name equals U. And there is multiple rows equals U. Yes, there is. So we say limit 1 offset 4, and we get the fourth row, 0, 1, 2, 3, 4. So this essentially means offset 0, limit 1. This character, this should work. So let's go back to our attack. Column name 1, RU equals an A, offset, that we're going to leave the offset on 0 here, so we're in hard code. So I think this should, did this not work, really? Did this not work? No, it did not work. Why? The offset keyword. Offset 0. What about offset 1? Oh, am I being stupid here? So let's not go here. Let's do columns where substring table name. So where table name equals webauth. Or let's just do, yeah, webauth. That's webauth, really? Can't remember what's in there, but I think it's just some demo stuff. And we do a substring column name here. Column name 11. RU equals RU. No, you're not. So we're going to remove this. Just going to learn about the database here. So we do have a bug here where webauth and yep. So where table like this. All right. So we're going to also remove this. So what columns do we have in a webauth column? Nothing. Beautiful. What about the users column? All right. So what we want to fetch, these columns from our target environment. So what we could do then is basically substring column name one character RU equals a U, right? This character U. We have 3 columns with this U. So if our hypothesis here is correct, this should return 3 rows. Substring error in the SQL syntax. Where's substring column name 11? Sorry, where's the error? Where is the error? Select star from information schema column where table name equals user substring. Is there a problem with my substring here? There is. Oh, I'm a noob. Too many bears last night. Okay, 4 columns being returned. Now with the offset, with the limit 1, offset 0, we get 1 column coming back. So let's just check our query. Table name. So we're going into columns where table name equals users. All right, it's very similar. In fact, it's equal. And substring column name 11, are you equal an A? And we get 1 row. Ooh. Here we go, B, C, D, E. Yeah, okay, gotcha. So that won't work. That won't work. The offset won't work because we're actually getting multiple results. The offset won't work. How do we distinguish from multiple columns? I mean, it's without doubt we can guess it. I mean, from the CyberChef output here, I mean, it's not hard to see that we probably have something along the lines of passwords and user, right? But how do we check? Oh, gotcha, gotcha. All right, so that's gonna be a bit more tricky. I think what we're gonna do is we're gonna do the first column equals a P, and then we can do an and. We can basically build our query up like this. And the second character, substring column name, the second character, your equals an A, if we're guessing correctly here. Yes. Aha. So we can basically, based on our knowledge from the character before, we can keep adding characters. So basically this P, so what if we have a sort? So P and A, and so we can basically say it's a second character, it's either an A or an S, right? So we said it was an A here, and it says this user exists, beautiful. But if it's an S, it doesn't exist. So that's a way to basically conclude that there is actually a password and users table. There might be an easier way, but basically password and user table. This is probably a false positive, not name. Name. It's probably a name as well. Username. Gotcha. Username. There we go. Username. All right. So moving on with our exploitation then. Had to do some serious thinking on that one. We want the password for the Natas15 user, if I remember correctly. So why don't we expand our attack then? So let's do this here, information schema columns. So let's not select from information schema columns. Let's select from the users table, from users, where the username equals Natas16, and the substring of the password column is the password equal an A. Limit 1 offset 0. Gotcha. We don't necessarily need this limit right now. I don't think about it, but let's just keep it in there because I don't want to wrap my brain around it right now. So let's check here. Is the password of the Natas user, does the first character start with an A? No. A B? No. Let's automate this. Let's do this. So we do this. We do this. Payload. Only one payload. So we're going to do sniper attack. We're going to do a brute force. And we're going to do one character. Oh yeah, there we go. You can see that we have results that is different. So this result here, W, this one produces this user exists. However, notice that we're not doing uppercase here. So let's do an uppercase as well. GHIJKLMNOPQRST. Oh, all right. I believe that's the alphabet. Might be in the wrong order, but who cares? And here we're seeing some very interesting artifact. We're seeing that both W and capital W is returning that the user exists. And that's a problem for us. We need to be case sensitive. And the substring command here is by default not case sensitive. My SQL is very forgiving, to say it like that. Okay, so pretty much anything you do in my SQL will work. But we need to have it to be case sensitive. And I believe we can add the binary keyword in front of here equals binary B. What about binary W? This user does not exist. What about binary W here? Oh, and it exists. Beautiful. So binary keyword works. do binary, then we check all uppercase, all lowercase. For this character, we find that it's a capital W. What we need to do now is for us to walk the entire password string. Now, if this password is anything like the ones before, we're gonna have to walk up to, say, 32 bytes. So up to 32, one step at a time, and we're gonna do the brute force also with uppercase letters. You know what? I don't want to make any mistakes here, so I'm gonna do this to uppercase. Beautiful, beautiful. Cheating, huh? But I don't want to. Well, I don't want any typos to make my attack not work here. And then we do start attack. We're gonna sort on content length. Ooh, we're getting stuff coming back. No uppercase letters yet. That's got me a bit concerned. Oh, that's because we're not starting working on uppercase passwords yet. So I think we're getting this. I think it's gonna work. So no uppercase characters yet because we haven't gotten into this piece of the character set yet. Okay, so we're gonna expect to see uppercase letters coming in soon. If we sort on this column here, you will see that X, Y, Z, and it will then start numbers and then uppercase, and that should give us some results. Database seems to be struggling though. Whenever you see this happening, whenever you see lag like this, tread very carefully. You don't want to be the reason that you're crashing a target system here, okay? You don't want to be the reason that your customer goes down, for example. That would be very bad for you. So try not to have that happen. However, I'm running against my own database, of course. No, I'm not. I'm running against over the wire. Are you feeling okay, sir? I think we're okay. Oh, it's a bit laggy. I could potentially treat this database a bit more nicely. If you look at the response completed, though, that's what I'm interested in seeing. I think my computer is just lagging because the MySQL Workbench, for example. Oh, look at this. 12 seconds reply from over the wire. We are not behaving very nicely with our 2000 requests here. Whoever gets the job done. Ideally, we would set the number of threads here down to a 1 or a 2, but really, I don't want to wait right now, so I'm just gonna hit it with full force. But this is potentially causing some lag, or maybe there's a web application firewall here, which is throttling me a little bit to prevent me from running too many requests. But whenever you see this graph of response completed go up like this, that's a sign of concern. You must be very careful with the availability of your target system so you don't crash something. All right, so it looks like the execution is almost finished here. Just about 100 more requests. And we do have uppercase here, we got uppercase here, and I'm just gonna bring this into Excel once it's done here. Gonna go full screen. So you can see that from here we have all the way up to 32. Let's hope that there is no more characters more than 32, but at least this will give us a start. So we're gonna paste it into Excel again. We're gonna sort on column B again. And according to this, the password is this column here. So we're gonna bring it into CyberChef. We're gonna split away the new line. And we're gonna join on nothing. And this should be the password for Natas15. There's only one way to find out, and that's by going to Natas15, trying it. Natas16, didn't have to copy paste that one, but this one. Oh, the lag is good. Oh, the suspense, and we got it. Yes, perfect. So that's blind injection. I'm sorry with the mistakes in the middle there. I'm doing these videos all in one take anyways. I have done these challenges before, however, it's a long time ago, and those multiple rows coming back, having to defeat that with burp suit, I'm sure I can come up with a clever way of doing it, but during this take, however, I couldn't, so I would have to think about that a little bit so we can potentially have the burp suit add the previous character all time. So the first column is P, yes. So what's the second character then? While the first column is still a P. So that's the way to enumerate that, probably in a better way. So I don't want to delay this video anymore. We're already 40 minutes in. That's crazy. So I want to say thank you for listening. My name is Chris Dale, and I will have another video out soon, I hope, where we're going to look at finding words containing something beautiful, I'm sure. All right. Bye-bye. Thank you very much.